Good morning. I am Dr. PMShanthi, working as Assistant Professor in the Department of Information Technology, JJ College of Arts and Science for the Kotai. Now we have to discuss about the concept of parallel databases in the advanced database systems. Parallel database means the transaction requirements of organization have grown with increasing uses of computers. The growth of the World Wide Web has created many sites with millions of viewers, and the increasing amounts of data collected from these viewers has produced extremely large databases at many companies. Organizations are using these increasingly large volume of data, such as data about what items people buy, what web links user click on, and when people make telephone calls, to plan their activities and pricing. That is, the queries used for the purpose of called decision support queries, and the data requirements for such queries may run into terabyte. The set-oriented nature of database queries naturally lends itself to parallelization. A number of commercial and research systems have demonstrated the power and scalability of parallel processing. Queries are expressed in high-level languages SQL, structured query language, translated into the relational algebra. Different queries can be run in parallel with each other. Concurrency control takes care of conflicts. As microprocessors have become cheap, parallel mechanisms have become common and relatively expensive. Thus, the database naturally lend themselves to parallelism. The next one, I/O parallelism. I/O parallelism refers to reducing the time required to retrieve relations from disk by partitioning the relations over multiple disks. That is, the most common form of data partitioning in a parallel database environment is horizontal partitioning. In horizontal partitioning, the tuples of our relations are divided among many disks so that each tuple resides on the disk. Several partitioning strategies. First one, partitioning technique, Roundrobin method. Another one, hash partitioning, and then another one, range partitioning. Roundrobin is that is send that ith tuple inserted in the relation to disk I mod n. That is, the strategy scans the relation in any order and sends the ith tuple to disk number capital Di mod n. The round robin scheme ensures an even distribution of tuple across the disk. That is, each disk has approximately the same number of tuples as the others. Another one, hash partitioning. Hash partitioning is a choose one or more different attribute as a partitioning attribute, and then choose a hash function h with the range 0, 1, n minus 1. Is it each tuple of the original relation is hashed on the partitioning attributes. If the hash function returns I, then the tuple is placed on disk Di. Range partitioning. The strategy distributes tuples by assigning contiguous attribute value ranges to disk, and the partitioning attribute A and the partitioning vector B0 comma v1 comma v2 comma vn minus 2. If I less than j, then vi less than vj. The relation is partitioned as follows. This is an example. Tuple t such that t of a equal to x. If x less than v0, then t goes to the disk d0. Suppose if x greater than or equal to vn minus 2 goes on the disk capital D n minus 1. Suppose if vi less than or equal to x less than vi plus 1, then t goes to the disk di plus 1. And then comparison of partitioning technique. There is here evaluate how well partitioning technique support the following data access. That is, it refers rates for reading or writing and entire relation are much faster with I/O parallelism than without it. Access to data can be classified as first one scanning the entire relation, second one locating a tuple associatively, that is for example employee name equal to AAA. This query is called point queries. Seek tuples that have a specified value for a specific attribute. Third one, locating all tuples for which the value of a given attribute lies within a specifying range. Example, 10,000 less than salary less than 20,000. These queries are called range queries. The different partitioning techniques support these type of access to different levels of efficiency. Round robin, hash partitioning. Round robin method, this scheme is ideally suited for applications that wish to read the entire relation sequentially for each query. That is, with this scheme, both points queries and range queries are complicated to process since each of n disk must uses the search. Hash partitioning. This scheme is the best suited for point queries based on the partitioning attribute. Here, good point queries on the partitioning attribute can look up a single disk, leaving others available for answering this query. And the index on partitioning attribute can be local on disk, making lookup and update more efficient. No clustering, so difficult to answer range queries. And then another one, range partitioning. It provides a data clustering by partitioning attribute value, good for sequential access, good for point queries on the partitioning attributes. Only one disk need to be accessed. For range queries on partitioning attribute, 1 to 4 disk may be needed to be accessed. The remaining disks are available for their queries. Good if the result tuples are from 1 to a few blocks. If many blocks are to be fetched, they are still fetched from 1 to a few disks. And a potential parallelism in disk access is best. Example, executions queue. Partitioning in a relation across disk. If a relation contains only a few tuples fit into a single disk block, then assign the relation to a single disk. Large relations are preferably partitioned across all the available disks. If a relation consists of m disk blocks and there are n disks available in the system, then the relation should be allocated minimum of m n disk. and then handling of skew. The distribution of the tuple disk may be skewed, that is, some disks have many tuples while others may have fewer tuples. Types of skew: attribute value skew and then partition skew. Attribute value skew means some values appear in the partitioning attributes of many tuples. All the tuples with the same value for the partitioning attribute end up in the same partition. Partition skew with the range partitioning, badly chosen partition vector may assign too many tuples to some partition and too few to others. Less likely with the hash partitioning if a good hash function is chosen. Handling a skew in the range partitioning. To create a balanced partitioning vector, that is, sort for the relation of the partitioning attribute, construct the partition vector by scanning the relation in sorted order as follows. Alternative technique based on the histograms used in the practice. Inquiry parallelism. The queries transactions executed in parallel with the one another and then increase the transaction throughput used primarily to scale up a transaction processing system to support larger number of transactions as per second. More complicated to implement the shared disk or shared nothing architecture. That is, locking and logging must be coordinated by passing messages between the processor. Cache coherency protocol. Example: cache coherency protocol for shared disk system. Before reading or writing to a page, the page must be locked or shared exclusive mode. On locking a page, the page must be read from the disk. Before locking a page, the page must be returned in the disk if it was modified. More complex protocol with the fewer disk, it reads, writes exist. In the remaining concept, it can discuss in the upcoming session.